Good morning, students. We have already started our chapter solid state. In solid state, we have seen types of solids, that is crystalline solid and amorphous solids. Crystalline solids, the solids in which constituent particles are arranged in regular manner and periodic over a long range are called crystalline solids. Then there was types of crystalline solids: ionic solids, covalent solids, molecular solid, and metallic solids. Out of them, we have learned characteristics of ionic and covalent solids in previous periods. Now we are going to study characteristics of molecular solids. So, what are molecular solids? The solids in which constituent particles are molecules. They are called as molecular solids. Molecules like chlorine, methane, hydrogen, oxygen. On solidification gives molecules. In these types, the solid molecules are held together by dispersion force or London forces or hydrogen bond between them. There are some characteristics of molecular solids. The constituent particles are molecule. Then the bond present in these molecular solids are covalent, and molecules are held together by various intermolecular forces, uh, like first weak dipole-dipole interaction in polar molecules like hydrogen chloride, then water and sulfur dioxide, which contain permanent dipole moment. Then second, very weak dispersion force or London force. This is present in non-polar molecule like methane, hydrogen. They are present also in monoatomic molecule like neon. Then third, intermolecular hydrogen bonding present in ice, H2O, then ammonia and hydrogen fluoride. Then they have low melting point due to weak intermolecular forces, and they are poor conductor of electricity and are used as insulator. So this was characteristics of molecular solids. We will revise again. Molecular solids, the molecules in which constituent particles are molecules. They contain different types of forces: weak dispersion forces or London forces or hydrogen bonds. Characteristics: constituent particles are molecule. Then three types of forces: weak dipole-dipole interaction in polar molecule like water, then hydrogen chloride, sulfur dioxide. Then weak dispersion forces or London forces present in non-polar molecule like methane, hydrogen. They are also present in monoatomic molecules like neon. Then intermolecular hydrogen bonding in H2O, ammonia and hydrogen fluoride. They contain, also they have low melting point due to weak intermolecular forces. Then they are poor conductor of electricity and are used as a insulator. So here is fourth type of crystalline solids, that is metallic solids. So metallic solids are the solids in which positively charged metal ions are constituent particles which form in metallic crystal. In these solids, the metal atoms convert into metal ion by contributing one or more valence electron to form the sea of electron like this. Metal atom is converted into metal ion by contributing one or more electron. These electrons are free to move in that metal and cations are fixed. Then the positive ions of metal ions are arranged to form a kernel in the sea of delocalized electron. There is force of attraction between this positively charged ion and electrons. From this diagram, it is clear that electrons are delocalized and not localized to particular metal ion. So some characteristics of these metallic solids: metals are malleable, they can hammer into sheets. Then metals are ductile, they can drawn into wire. Then we know that metals are good conductor of heat and electricity. Some examples like sodium, magnesium, copper, gold. So these were metallic solids. Here is diagram. Electrons are free to move, they are delocalized. Here in this chart, the characteristics of ionic, covalent, molecular and metallic solids are given. So types, here first type ionic solid, properties are particles of unit cells, they are cations and anions. Then interparticle forces, here electrostatic force, then hardness, they are hard and brittle. Melting point of ionic solid is high, from 600 to 3000 degrees Celsius. Then thermal and electrical conductivity, they are poor in solid state, but when dissolved in water, they are good conductor of electricity. And examples: sodium chloride, then potassium chloride and calcium chloride. Then second type, covalent network solid. Here particles of unit cells are covalently bonded. Bond, intermolecular bond is covalent bond, or interparticle bond is covalent bond. Hardness, it is very hard. Then melting point, from 1200 degrees Celsius to 4000 degrees Celsius. Then they are poor conductor of electricity, but here graphite is good conductor of electricity and diamond is good conductor of heat. Examples are diamond, silica. Then molecular solids, here particles of unit cells are monoatomic or polyatomic. Forces we have seen earlier: London forces, dipole forces and hydrogen bond. They are soft, their melting point is from minus 272 degrees Celsius to 400 degrees Celsius. They are poor conductor of heat and electricity. Example: ice is water, H2O, benzoic acid. Then metallic solids. Metallic solids in unit cells are metallic ion in the sea of electron. Metallic ion in the sea of electron. Then interparticular forces, metallic bond. There is force of attraction between cations and electrons. And they are variable from soft to very hard. There is wide range of melting point from minus 39 degrees Celsius to 3400 degrees Celsius. Then they are good conductor of heat and electricity. And metals, here some soft metal like sodium, magnesium, and hard metals like copper, gold, silver. So this was the characteristics of crystalline solids at a glance: the ionic, covalent, molecular, and metallic solids. This chart is also given in our textbook. So in one glance we can see four types, their properties, examples. Thank you.